Start recording now. Okay, so on the last video, we did a little bit of this calculator stuff, but I'm doing it all over again because we haven't done that in a period. So we're looking at number 4 on your 4.2 notes. Is everybody there? Awesome. Okay, so I told you we need our calculators out. What I want to do first is I'm actually going to do this backwards of what I did my other class, just because I think it might actually be a little easier. I want everyone to hit mode on your calculator. And I want your, the third line on my calculator is probably the second, third, or fourth line on your calculator, says degrees and radians. I actually want the radians button clicked now. When you plug in sine, cosine, tangent, whatever unit you're putting in, that's the mode that you need to be in on your calculator. So we're actually going to do radians first because I think it's a little bit less math than the degrees is. So everyone's in mode, everyone went to radians, everyone good with that? Before this, you didn't know what radians are. Now we know what radians are. Can you tell me?
How do we get out of there again?
Click second mode.
Yeah, well.
Second mode just puts you out. Which of these A through F are radians? Which of these A through F are radians?
C.
I hear C. I hear what else? D. I hear F. Why are those radians? They don't have a degree sign. Just that simple. Often, whenever there's a pi, then that is a radical. Nope, those are the wrong words. Whenever you have a pi, that's a radian. And then whenever you do not have a degree sign, that's also a radian. Let's do letter D, cosine of pi over 9 first. You have the buttons sine, cosine, tangent. So if I ask for sine or cosine or tangent, we just simply press that button. To get 9 or pi divided by 9, we just simply put pi, division sign, 9, and then close your parentheses. That is enough. And whenever we do trig functions in our calculator, I want you to round 4 places. So go 4 places after the decimal. So I'm going to write 0.9397. So since this was just cosine, all I did was press the cosine button. I press pi, I press division sign, I press 9. Cool. The other 2 radians are not as simple, right? So if you're like, okay, that seems like great logic, let's go do cosecant of 5 pi over 16. And then you're like, Miss White, there is no cosecant button, right? That's okay. Do you remember which trig function cosecant is the reciprocal of? Not -1. We're not going to do -1. I'm going to explain that in 1 second. Which one does it go with? Sine. Good. When we do the reciprocal, we represent that by doing 1 over sine of that angle. We are about to use sine to the negative first, cosine to the negative first later. Those are the inverse functions, not reciprocal, so they're not the same. And that's a great thought process. You're like, oh, I'm just going to do the opposite of it, sine to the -1. That means something a little bit different. So we're doing 1 divided by sine, and then I'll do 5 pi, oop, that's E, 5 pi divided by 16. I don't know how this calculator works, so I'm probably going to do my 5 pi divided by 16 first, and then I'm going to do my 1 divided by sine of that answer. I'm a little once bitten, twice shy about the calculator. When I was in school, we had to be super diligent about certain things. You might be able to plug a few more things in and still get the right answer, but the answer we should get here is 1.2027. And so if you don't do that, if you did not get that, I would break your answer up a little bit like I did. So I did my 5 pi divided by 16 first, and then I did 1 divided by sine of that answer.
What do we do for B again? Or what answer do we get?
B, I got 0.9397.
And then so that means for the next one.
So we're going to do F next. What should we do?
1 over tangent.
Very good.
2, and it's just 2, right?
It's just 2. So there's no pi on here. This is just tangent of 2. And I know it's radians, and I'm still in my radians mode. I haven't switched out. 1 divided by tan of 2. And we get negative 0.4577. We will get to a place where we'll talk more about patterns and what kind of answers we should be getting from here. But negatives are okay. These big decimals are okay. 1 with a big decimal is okay. All right, those were all radians. Let's switch our mode. Let's go to degrees. So go back to mode, and we are currently clicked on radians. I want to click over to degrees, and I want that to be the word that's highlighted in that line. So we are now in degrees, and I think the easiest one is to do is secant of 10 degrees. So in a second, quit out. Since there's no secant button, what am I going to press in here to represent secant? Secant is the same thing as 1 over cosine, so we'll do 1 over cosine 10. And I had just put my calculator in degrees. If you forgot, remember, go to mode and make sure your degrees is the one lit up. So I'm going to do 1 divided by cosine of 10. And now my 10 is in degrees because that's what I told it. That's the unit I told it that we're in. And so that's 1.0154. The last two, you might have looked at that and thought they were the easiest ones because they were tan and sine, so we don't have to do 1 over anything. The reason I put them last, though, is because I have to do a little conversions to go from degrees, minutes, seconds into decimals. So I'm currently at 28 degrees and 11 seconds. We need to make 11 seconds into a decimal. Do you remember how we do that?
Divided by 60.
Divide by 60, 11 minutes divided by 60 minutes is my degree. That will get me into degrees.
0.183 repeating.
I'll just make it 0.183. That, and I don't have to do anything else because there's no seconds here. That's it. I am now going to put in my calculator tan of 28.183 degrees. Again, my calculator is already in the mode degree, so I don't have to physically put my degree sign in, but I'm just going to type tan 28.183, close my parentheses, and that will give me my answer. 0.5358. And then the last one here is just like that. We just have to do degrees and minutes, or so we have to do minutes and seconds to get both of those into degrees. Get both of those into degrees. So when I move on to letter E, I'm going to make 18 minutes into degrees by dividing by 60. And I'm going to make 13 seconds into degrees by dividing by 3,600. My first decimal is 0.3. My second one is 0.0036. So that means I'm going to type in sine of 129.30361 into the calculator. A big mistake is that you guys put all this work into doing the decimals, and you get that decimal, and then you forget the 129 in front. So don't forget to carry that degree in front with you. So I don't want sine of 0.3036. I want sine of 129.31 or 3036. And that answer is 0.7738. Get that zoomed in a little bit right there. All right, so those should be pretty gimme questions if I put that on a quiz or a test, because we're just plugging it into the calculator. There's a couple weird things though, so that's why I wanted to bring that to our attention. The last two concepts we're doing today, I believe I taught you in geometry. It's just been a minute since we've done them. So there are two problems at the bottom of the page, and then there's a whole side of word problems. I'm here to do all of the word problems, but if we run out of time, I'll just do as many as I can. They're all very similar though, so I just am trying to get as many reps in as possible. Cool. Can I move on from this? Okay. The bottom of the page, and I'm going to leave my calculator up because I do need it down here. These say solve for the variable shown, use your calculator. So I'm going to zoom in on the first one. I've got a 57 degree up here in the top corner. When I say solve for the missing side and I give you one side and an angle, you can't do Pythagorean theorem because I only have one side. In order to do Pythagorean theorem, you need at least two sides. At this point, I'm going to use SOHCAHTOA. I'm going to use sine, cosine, or tangent, depending on what is given to me, depending on what my options are. So if 57 is the degree, if that's my point of view, what sides are given to me? What do we call 32? Opposite. And then what do I call y? Hypotenuse, good. And which trig function is that? Sine. SOA. So, well, I get my words together before the rest of the day. So, sine. So I'm going to do sine of my angle 57 equals opposite, which is 32, divided by hypotenuse, which is y. Does this ring any bells? I know I taught this to you. This might have been March 2020. No mems. What'd you say? It's not ringing any bells. I swear on my life I taught this to you. Not all of you. I didn't have the luxury of having all of you, but a couple of you. I know happened. All right, so now that we're here, I need to get y by itself, and I'm going to simplify this down and then just put one big thing in the calculator. So in order to get rid of this fraction, we don't want the denominator, right? So let's multiply by y on both sides to cancel out that y. Y times sine of 57 equals 32. And then last but not least, I want that y all by itself, so we divide off sine of 57 from both sides. And so what I'm putting in the calculator, what y is going to equal, is whatever 32 divided by sine of 57 is. And I'm just going to physically type that in. So 32 divided by sine 57. I'm still in degrees. If you have like put your calculator away, done some things and come back, I would go make sure in your mode that you're in your degree mode, because that's what I'm about to put in. But I'm just going to physically type 32 divided by sine of 57. And my answer is 38.2.
If your calculator is in RAS,
It will be wrong.
will it be like a drastic?
It will be, I think it'll be pretty drastic. Here, I can just kind of experiment with that really quick on this one, just to show you. Sometimes it's drastically different, and then sometimes it's like not that far off. So like 73, like I think that's pretty drastic, but like if you aren't like thinking that hard about it, or if you're like, oh, well, this side's 32 and this side must be bigger, like that is a bigger number. It's not drastic enough to like just see it and notice it. So I would always check and make sure I'm in degrees. All right, we're gonna do one more just like that. All right, this time 71 is my angle. What two sides do I have?
18x.
18 and x, which are O and A. O is 18, x is A. So which function is this? TOA, tangent. What am I going to write? What's my equation I'm going to write? Tan 71 equals 18 over x. Good. And this is the same math we just did a minute ago. So how do I start getting x by itself, Cam? Multiply by x. X tan 71 equals 18. Divide by tan 71. And so x equals 18 divided by tan 71. And so I'm just going to put that right in my calculator. All right, whether or not this rings some bells, are we doing okay with this? Not too bad, right? Sine, cosine, tangent, just simplifying, finding all my right answers. We're going to flip our paper over, and we're going to do as many of these word problems as we can. Got 1, 2, 3, 4, 5. My biggest hint to you is anytime you see a trig word problem, draw a picture. Draw a triangle. That will really help you keep everything organized. Everything we're doing on this page is still my SOHCAHTOA stuff, so I am going to write SOHCAHTOA at the top of my page, just in case I forgot. Draw a picture for the following, then write an equation and solve it. Round to the nearest hundredth. So we're going to round 2 places after the decimal. All right, first problem says a squirrel is sitting at the top of the tree, which is 52 feet tall. He is looking at a nut on the ground. I'm just going to stop right there and I'm going to draw a triangle. You can be fancy, like when I have my geometry kids, I like draw like a real tree just because we like have time to do that for us. So I'm not going to get all fancy with you, but I am going to label it. So it says the squirrel is sitting at the top of the tree. So I'm going to put an S at the top because that's where the squirrel is. It says there's a nut on the ground in front of the tree. And then I'm just going to put a T at the base just because it's a tree. So I'm going to remind myself what everything is: squirrel, nut, tree. Those are the kind of important things we have. It says the tree is 52 feet tall. That's my vertical distance, right? Trees grow up and down. So 52 feet is my distance from S to T. And then it says angle of depression is 23 degrees.
So that's what the S is, right?
That's where my S is. And if I'm thinking about where my S is, am I looking up or am I looking down? I'm looking down. So this might seem so silly, but like whenever I do angle of elevation or depression, I literally put my arms out in front of me. I keep one arm straight, and elevation means I'm looking up. So this is like what my angle should look like. And depression means I'm looking down. So then that means like the flat part is across and then the angle down. I have to draw a fake line up top because I don't actually have one. So I draw a fake line up top and my angle of depression is going down this way. It is never the angle between the tree and then the like line of sight. It's always from like flat where the squirrel is and then looking down. That angle is 23 degrees. Now, because that angle is 23 degrees, I actually can label the angle at N as also 23 degrees. Does anyone know why that is also 23 degrees? Not sup.
It's like the opposite. It's like the same.
Good. Well, basically, like I've got parallel lines and I've got, do you remember this word? Alternate interior angles. Hannah does. Good. Kind of blast from the past, right? Alternate interior angles. I don't expect you to remember that theorem from geometry, but that's something that like we learned a long time ago that now we're going to use. Hint, that's your angle of depression and this is your angle of elevation. They are the same. They are the same always. Always, always, always. Okay, so that's helpful. Then it says find the distance from the nut to the base of the tree. So I'm finding the distance from N to T. That is going to be X. So I played all of that out just so I could label this nice pretty triangle. And so now I have my angle of 23. I need to label 52 and X as opposite, adjacent, hypotenuse. And then I have to use my trig function. What is 52? Good. What's X? Adjacent. Good. Which trig function am I going to use? Tan. So I'm going to say tan of 23 equals 52 over X. Good. Great. We just spent like 10 minutes doing this with two other problems. So we're going to solve it the exact same way, simplify the exact same way. Multiply by X, divide by my tan. Got to get rid of the variable to do anything. And then we're going to divide by tan 23. Make sure you're still in degree if you've been playing around with your calculator. I am. So X, it's in feet, so I got 122.50 feet. And that's what I got last time I did it. All right, we doing okay? All right, let's do the next one. The next one says a seagull on top of a lighthouse spots a fish in the water below. Okay, stop. Let's draw a picture. Draw a triangle. A seagull on the top of a lighthouse. So the seagull's at the top. This whole vertical structure is a lighthouse, and it spots a fish in the water out in front of the lighthouse. It will always be a right triangle. The only way you can do this is a right triangle. The goal, the sea goal, is 87 feet above sea level. So that is a vertical distance. So that's how high he is on the light pole, or on the lighthouse and the ground, I guess. Or else I'd be a really tall lighthouse. And it says he is 230 feet away from the fish. What distance is that? Is that SF or is that FL?
FS,
FS.
the seagull, right?
The seagull.
To the fish.
It says he is 230 feet from the fish. The reason I make a big deal about that is we do not often use that distance. You do every so often, but that's a really weird distance to measure. It's a lot easier to measure like vertical distance and horizontal distance. So this kind of weird, like sideways distance is weird. It says now find the angle of depression from the goal to the fish. So we just practice finding the angle or having the angle of depression. That's this angle right here. Which angle is that also congruent to? The bottom one, the one at F. Good. So this is the theta that I'm trying to find. What sides do I have here? I have H, and then what's 87? O. O. So sine. So I'm going to say sine theta equals 87 over 230. All right, normally on all of these other ones, I would take like a number. I'd say like 87 divided by sine of 23 or something. We don't have that here. Instead of trying to find the angle, this is where, Hannah, remember a minute ago you said sine to the -1? This is where we're going to use my inverse sine. So since I'm trying to find the angle, I can't do regular sine of this. We're going to do sine to the negative first, which is the inverse function of my ratio. If I have a ratio and we do inverse sine, then my answer is going to be an angle. So I'm going to do not normal sine. I'm going to press second sine. So I can see sine to the negative first. So second sine, I'm going to do 87 divided by 230. So my angle, my theta, is 22.23 degrees. Right. All right, let's keep going. You ready for the next one? All right, letter C says, how far is an airplane from the airport if he is currently 5,000 feet above the ground and the pilot's angle of depression to the airport is 17 degrees? So airplane from airport if he is currently 5,000 feet above the ground. In this case, my triangle, my airplane is not physically above my airport. My plane is up here in the air, and the airport, I'll use an A for airport, is down here on the ground. This really doesn't have like a specific point. This is just if I were to drop like a straight line up and down. Okay, it says he's 5,000 feet above ground. Where do I put that on my picture? P to whatever. Yeah, it's that vertical distance, right? 5,000 feet is my vertical distance. And then it says the pilot's angle of depression to the airport is 17 degrees. So we can draw our angle of depression. We also can remember that which other angle is 17 degrees? I heard it, A. Very good. And then it says, how far is the airplane from the airport? Which distance is that? P to A. Very good. There's my hypotenuse. It's that slant distance. I'll actually use an X there. I'll use an X there to represent that. So that's slant distance. All right, so if my angle is at 17, what two sides do I have? O and H, which is which function? Sine. Good. Sine of 17 equals opposite, which is 5,000 over X. We've solved this like 3 or 4 times at this rate. Multiply by X. Divide by sine 17. You do not have to show me all these steps if you already know the pattern or what's going to happen. I'm just still kind of showing it out to you while we're still getting familiar with it. I'm physically putting 5,000 divided by sine of 17 in my calculator. And I get an outrageously big number, but this makes sense because I'm 5,000 feet in the air. So I might be 17,101.52 feet away from the airport. Those are not crazy numbers when we're talking about airplanes. All right. I know the cleaning bell is going to ring in a minute, but I think I can get through these last two. Okay. Letter D says, find the height of a flagpole that makes a shadow 13 feet long when the angle of elevation to the sun is 59 degrees. All right, draw your picture, see what you label it. It says, find the height of the flagpole. What distance is that? The vertical distance. And then it says my shadow is 13 feet. Where is that? Good, it's like flat on the ground. And it says find the angle or find the height when the angle of elevation is 59 degrees. Where does 59 go? In the bottom. All right, let's label what sides do I have? Opposite and adjacent, which is which function? TOA, tangent. Tan of 59 equals x over 13. Ooh, and we haven't done one like this, but this is a really easy one to solve. So before we were multiplying by the denominator and then we had to divide because our denominator was where our variable was. This time we're just going to multiply by 13 and I can simply plug 13 tan 59 into the calculator and I'm going to get my answer. I get 21.64 feet.
So does that mean like the vertical distance is always going to be like on the top of a fraction?
In this case, with its tangent. So if I have vertical and horizontal distance, then yes, because that's my opposite. All right, last one. What is the angle of elevation of a man looking at the top of a building that is 48 feet tall that he is standing 100 feet away from? Okay.
So angle is what we're looking for.
Angle is what we're looking for. If I could draw a triangle, that'd be cool.
100 is the bottom.
Is my horizontal distance because my man is standing away from a building. My angle of elevation means I got to put a theta. I got to put a variable in for that. And then it says the building is 48 feet tall. So where does 48 go? My vertical. If theta is my angle, which sides did I give you? O and A, which is which function? Tan. So I'm going to write tan of theta equals 48 over 100. Wait, how do I do this again? How do I plug this one into my calculator? Not reciprocal. Opposite. Let's use the word inverse.
Use the -1.
Use the -1. So I want to use the word inverse to represent that. So theta equals tan to the -1 inverse tan. 48 over 100. Second tan, 48 divided by 100. Theta equals 25.64 degrees.
Did you make it go to the -1 in your calculator?
Second and then tan or second sine.
Okay.
All right, thanks for letting me teach during that cleaning bell just so we could get all of these in. We have now finished 4.2. So your 4.2 homework is due next class, which I believe is Thursday.
Why is it not 100 over 48?
It's O over A, and the man is 100 feet away from the bottom of the building. So that's like my horizontal distance. And the building is 48 feet tall, which is your vertical distance.
Do you have office hours on Wednesday?
I actually have to do NWEA on Wednesday.